Alright, welcome back everybody. In this video we're going to talk about integrating vector-valued functions and look at a few examples related to that. To find an indefinite integral of a vector function, basically all we're doing is we're taking the antiderivatives of the components of that vector-valued function, and then we have a constant vector out here on the end. Alright, so let's take a look at how this works. Example 1, we're going to find r if dr dt equals negative sine of ti plus cosine of tj. So our vector valued function r of t, I'm just going to take the indefinite integral of this component, and that is going to be cosine of t. So it's going to be cosine of ti. And then I'm going to take the indefinite integral of this component. That's going to be sine. And so there's my function. Cosine of ti plus sine of tj. Oops, I forgot something very important. Slap my hand. Plus my constant vector. Alright. And now we can apply this into initial value type problems. We've got dr dt equals the given function there. And so we're going to take the antiderivative of each of these components. The antiderivative of 1 over t squared plus 1 is going to be the arctangent of t. And the antiderivative of t over the square root of t squared plus 1 is going to be what? Well, if I do substitution here, u equals t squared plus 1, du equals 2t dt, so 1/2 du is equal to t dt. So this turns into the integral 1/2 du over the square root of u, and the antiderivative of du over the square root of u is just 2 root u, so this ends up just being the root of u, so the square root of t squared plus 1. Plus my constant vector. And now I need to solve for the constant vector, and I know that this, when t is 0, it gives us the vector I plus j. So r of 0 is equal to the arctangent of 0 I plus the square root of 0 squared plus 1 j plus the constant vector. And so we get I plus j is equal to, and the arctangent of 0 is just 0, and this gives me j plus the constant vector, and so the constant vector is equal to I, and now I'm just going to absorb that into the function, the component of I, and so it's going to become arctangent of t plus 1 I plus the square root of t squared plus 1 j. And there's our initial value solution to this particular situation. This is the vector valued function whose derivative is given, that has the given initial condition. Alright, continuing on. For a definite integral, in order to find the definite integral, all I'm going to do is take the definite integral of each of the individual components. And so to evaluate the indefinite integral from 0 to 1 of this vector valued function, it's just going to be the integral from 0 to 1 of 3 plus 6t I, put a dt in there, plus the integral from 0 to 1 of 6 pi cosine of pi t. I need a dt again. J. And now I want to find these definite integrals. Do I want to do these by hand? I don't know. Could certainly do them by hand. Just feeling a little lazy. We get 6i plus 0, j. So we just end up with 6i. And so when we take the definite integral of a vector-valued function, what we're going to end up with is we're going to end up with some vector. In this case, 6i. Alright, that's where we're going to call it quits on this video. We'll come back in the next video and look at examples 4 and 5 from this lesson. See you guys then. Have a great rest of your day.